Let's learn how to use NI-MIDAC as an oscilloscope. As we're getting started here, recognize that the two inputs for the analog inputs are limited to plus and minus 10 volts maximum input. Do not exceed that range of plus minus 10 volts. For this demonstration, I have a simple resistor capacitor circuit set up. This will give me a different signal to observe on the second channel. And for this demonstration, I actually need a signal source to apply to the oscilloscope. I'll use the function generator for this purpose. The function generator produces a signal which goes out to that resistor capacitor circuit. I can observe that on one of the oscilloscope channels. And then I use the output of the circuit on the second oscilloscope channel. So at the moment I'm applying a 100 Hertz sinusoidal signal and observing this on the oscilloscope. Now with triggering, I have the ability to select either immediate or edge type. With edge, I pick a threshold voltage and then a trigger point emerges on the screen. So again, the crosshairs for the red lines indicates the exact moment of triggering. And that's where the oscilloscope decides to launch the trace. So we see the indicating waiting for trigger when it cannot actually discover one. Also, the slope indicator tells us whether or not we're looking for a rising transition through that threshold or looking through a falling transition. Here I am varying the apparent amplitude of the signal just so we can see it a little bit better. I'm not actually changing the amplitude of the signal itself though. So with negative slope, then I can make the trigger occur on a falling edge of the sinusoid. I'd like to point out that if zero signal is being applied, then we just get this flat line. Again, back to immediate triggering, it just kind of triggers periodically. It's not necessarily synchronized to the signal source at all. Let's try a different wave shape. Also, let me vary the frequency of the input source. So you can get quite slow, such as about 3 Hertz in this case. And when you have very slow signals, then you need to adjust your time base so that each horizontal division accounts for more time. Notice that it takes a longer time for the oscilloscope to finish collecting enough values to be able to paint the entire screen. When you have a higher frequency input signal, then fewer samples are required to paint the entire screen, and so you get a quicker update. Let me go to 300 Hertz here, go to a square wave. At this point, let me invoke the second channel. As I mentioned earlier, that resistor capacitor circuit is developing an output on analog input 1. And in this case, where you're comparing inputs and outputs, it's good practice to set both vertical settings to the same volts per division. The blue trace tells us the channel 1, and the green trace, of course, tells us channel 0. Notice that you can adjust your triggering to trigger from either of those two channels. So again, you can see I'm triggering on the blue trace, which is our channel 1. The measurement cursors are a handy way to read numerical values from the oscilloscope trays. I'm presently looking at channel 0. So you notice that the C1 indicator abruptly jumps to track where it's at on the analog output 0 trace, or on the scope that's analog input 0. Now cursor 2 rather, can be used to look at the same signal, and this allows you to make measurements of, say, the time difference between the two signals, or in this case the two edges, and that's reported down here as dt. The cursor can also be associated with the other channel. I'm not trying to grab the label. Let's try it this way. So right now we're making measurements on the blue trace instead of on the green trace. Also wanted to mention that if you look carefully at the green line down there, you have additional measurements such as frequency, volts, peak to peak, and RMS. You can also get help on any of the features of the oscilloscope by typing Control H, and you can do that on any Elvis MX instrument incidentally. So type Control H to invoke the context help, wave your cursor over Control and see how it works.